Hey guys, I'm Thomas Cocker with the BCA, and I'm joined today with my mildly intelligent coworker, Chris Pilot. Say hi, Chris. Anyways, so we're called out onto site to troubleshoot issues with this lab/office building. Basically, a tab contractor had been stuck on this project for about 3 months, and the owner just wanted him done and off the project. Well, the reason he was claiming that he couldn't leave the project was because this exhaust fan pictured was about 80% of design. And then they were having building pressure issues because of it.
One thing not mentioned was the fan was 80% of design, yet the building was extremely negative.
Right, exactly. So how does that even happen? So we went out there to start troubleshooting. So when we went out on site, we saw that they were using a veil grid to calibrate the airflow valves on the fume hoods. And if you don't know what a veil grid looks like, it's this device up here, and you connect it to a Shortridge digital manometer. You can connect it to an Alnor or Evergreen. There's probably more brands out there that I'm missing, but basically this device reads a velocity, right? And if you look at the manufacturer spec on this device, it'll show that it's plus or minus 2% accurate. But the problem is that's not true for every application. Now, if you have a perfect area that always stays the same and you calibrated it right, you could, similar to a flow hood, you can potentially get that accuracy. But for, reading it out in this case, you cannot.
What Thomas was exhaustively trying to say.
Fun.
Please stop. Basically, the top left picture, the guy holding the veil grid in his hand like that. Can he repeat that for every single reading across that fume hood? The answer is no, unless if he's a robot. You can't do that. The same thing for the bottom right. That guy cannot repeat that same method that he is doing in every single reading. And if you hold that veil grid 3 or 4 degrees the other way, tilted, however you want to tilt it, it's going to read different. These are the most inaccurate airflow measurements devices that we have.
Yeah, not to mention standing in front of the airstream like the guy in blue is doing. You don't want to do that. Basically, you might be asking exactly why you can't read it that way. Other than the methods that Chris mentioned, if you look at the picture below, this is basically a quick little side view of fume hoods and where the airflow can enter a fume hood. Now, obviously, there's a bunch of different types of fume hoods, different orientations, different types of bypasses. So, your application may be different. But in general, this is a good diagram of most fume hoods that you'll come across. And so as you see, if the sash is open, you'll get airflow into the face of the fume hood, but you also have a minor bypass underneath here that you're going to miss all that air if you're just measuring the face. Now, I've seen some guys try and tape this up, but even so, you get air kind of coming in from the sides, and it'll bypass around your veil grid, and you'll never capture that airflow. And then in the other picture, I've seen guys lower the sash until you're only reading the area about the size of the veil grid, which is like a 1 foot by 1 foot grid. But even then, once you start lowering the sash, you get a bypass from above plus the bypass below. And then on some fume hoods, they even exhaust the cabinet beneath them. And so you'll have holes back here that'll also pull air through. And so this, Venturi valve is seeing all that air, not just the air going through the face, but the air going through the bypasses and the air coming from the cabinet. It's seeing all that, but you're only calibrating it for the air that's coming through the sash. So right then and there, you're going to be inaccurate, right? At least 5% off.
When you have a lab that depends on CFM offsets and you're calibrating your Venturi valves just by using the veil grid, all that airflow you're missing is creating a lot of missing air that's not accounted for, which creates massive pressure issues.
So you may be asking, well, then what's the right way to do it? So the best way to do it is a traverse, and you can use a pitot tube or an airfoil, but you want to grab a traverse either entering the venturi valve or leaving the venturi valve. Now, obviously you want to try and make sure you have a straight duct run to make the flow as laminar as possible. It's not, you know, you can't always choose what site you're going to be at and your inlet and exit conditions on the venturi valve, but I would trust the bad traverse location over using a Velgrid any day of the week. So this is your best method, is just traversing inlet or outlet, and then that'll make sure you're capturing all the air entering the venturi valve, and it'll give you your best method for accuracy and repeatability. So what we found with these venturi valves is their factory curves had been offset from anywhere from 10% all the way up to 40%. And so what we did was we had those factory curves put back to the factory settings, and then we went through and traversed them all. And so when we were done, I don't think we had a venturi valve that was more than 10% off. And that is pretty much the case with these venturi valves. They're pretty darn accurate from the factory. Now, I have had some jobs where they're as much as 15% off after doing a traverse, but it's pretty rare. So once we did that and we got them all done, then we took a total traverse on the exhaust, and we found that we're just over design CFM, like by about 5%, which is about where you want to be. And so that pretty much solved the building pressure issues, because we took a system that was, you know, as much as 20% off, and then we found that it was right on the money. If you enjoyed this video, please like and subscribe. We post these videos once a month. And remember, with the Velgrid, never, ever